So, where we left off, a physical change, you don't make something new. You change its appearance and everything, but it's going to be the same thing. So, you might make it smaller by dissolving or mixing it, but it's going to be the same thing. Chemical change, we make something completely new. Like we may burn something and make something new. We break it down and we break its atoms apart and rearrange them, right? That would take some super scientific processes, or we could burn it and do the same thing like cooking. Okay, cooking is a chemical change, but physical change, you have the same thing. So if we have some sugar cubes and we put them in a drink and they dissolve, but they're still there. We could actually cause that drink to evaporate and we could get the sugar back out. So physical changes, we could typically go back. Chemical change ain't no going back. We cannot go back to what we originally had. What we had before is gone. It is no more. It's not destroyed. It's just changed to something completely different. So we don't destroy matter. Remember, we can just change it. Let's talk about physical. So some properties about physical, like its shape, its size. When we change things, we change those properties. We might break a glass and make more parts and make it into more pieces, or we may dissolve some drink mix in some water, or we may chop up some herbs or toss a salad. But either way, it's basically still the same thing. It's just its properties, its physical properties have changed. With physical, some examples are cutting or tearing, or warming or cooling. You can melt and freeze things. You can evaporate and condense things. Condense means come back together and make them tighter, more tightly packed. Um, Boiling and dissolving. So all of these are physical changes. It's still the same thing. We just changed its physical properties. If you chemically change something, you make something completely new. Ain't no going back, like I said. So if we burn it or we use heat to change the atoms in something like on a Bunsen burner, like in a science lab, okay? Let's say we bake some cookies. I can't unbake those cookies. They're done, you know? And if I had fireworks, when you see fireworks, that explosion is a chemical change. That bright light is produced. Now, there are clues to chemical changes that we'll go over very soon. But today I just want to give you some examples. So, chemical change examples. If milk would go sour, like this one, this chunky milk, it's disgusting, but that is a chemical change. Jewelry or silver becoming tarnished, okay? That is a chemical change. When bread becomes toast, when we burn the outside of the bread to change it, we can't untoast that bread. Okay. When we have rust that forms on a nail, we can't unrust the nail. This is called oxidization. It is oxidized. That orange film that forms on it, that is literally breaking down that nail. And if we were to light a match, anytime typically you have fire, we're talking about a chemical change. Okay. Now let's do a little quick quiz. Is it chemical or physical? Slicing bread. Pause me. Take a guess. Is this physical or chemical? If you said physical, you are right. We are just changing its physical property. What about lighting a match? Physical or chemical? If you said chemical, you are correct. We've got a flame. That is chemical. What about roasting marshmallows? If you said chemical, you are correct. Let's take a guess at this one. Frying eggs. Physical or chemical? If you said chemical, you're correct. We cannot unfry those eggs. What about cracking eggs? That is physical. We didn't cook them yet. We just opened them up. Right now, over in Canvas, what you're going to do is answer these 3 questions as your exit ticket from this video. Good job today, you guys. Talk to you again soon. Bye-bye.